In this circuit, we wanted to determine the voltage V1 across this unknown resistance R and this voltage V2 across this unknown element represented by the gray box. Let's take a look and see what kind of loops we can draw that give us the fewest number of unknowns in a particular equation. If I loop up through here, through the 10-volt source, continue through the 3-volt source, and then loop back around through V2, let's call that loop 1. That's one equation and only one unknown. We can determine V2 directly from that. For my sign convention, as usual, I'll assume that if my loop enters a positive terminal first, it's a positive contribution. If I see a negative terminal first, it's a negative contribution. So down here, going this direction, I see the negative terminal on the 10-volt source. That's minus 10 volts. Through the 3-volt source, I'm going this direction with that loop. I see the positive terminal first. That becomes a positive 3 volts. Then going down here, I'm going this direction through this unknown element here. So I see the positive terminal of V2 first. That becomes a positive V2. That sums up to 0. 3 minus 10 is negative 7. Take that over to the other side. So V2 is equal to 7 volts. Now let's see what we can do with V1. Now that we've got V2, we could loop through here. So let's try KVL around loop 2. I'm going this direction through V2, so that becomes a negative V2. I'm going this direction through the resistor R, so that becomes a positive V1 contribution. And then through the 4-volt source, I'm going this direction. I see the negative terminal first, so that becomes a minus 4 volts. That brings me back to my starting point, so that sums up to 0. If I use this for V2, I get minus 7 volts plus V1 minus 4 volts is equal to 0. Negative 7 minus 4 is negative 11. Take that over to the other side, so V1 is equal to 11 volts. I don't need to do a loop that requires me to know V2 first. If we go around this entire outer loop here, call that loop 3. I go through this source, and this voltage source, so I have 3 known voltages. My only unknown voltage is V1, and I can write one equation and one unknown. So KVL around loop 3. If I start here, I enter the negative terminal of the 10-volt source, so that becomes a minus 10 volts. I'm going this direction through the 3-volt source. I see the positive terminal of that first, so call that a plus 3 volts. Down here, I'm entering the positive terminal of V1 first, so I add that. That's plus V1. And finally, going this direction through the 4-volt source, I end up with a negative 4-volt contribution. Minus 10 minus 4 is minus 14, plus 3 is minus 11. I take that to the other side, so V1 is again 11 volts. I get the same answer since I did everything right both times. And I could solve for both of these voltages without having to resort to using my answer from one case to find the other one.